Anything which you want to discuss? Okay, so let's do one thing. Let's continue to the same in the same continuation. Let's understand a few more things which is relevant and required to understand the concept. Which one is ours? Okay, let's take the new one better. Okay, so yesterday we have talked about PGCTL and PGCTL mode. We also talked about why do we need PGCTL and what is the importance of PGCTL, why we are not doing it from the root. Also, we understood the little bit part of the automation to check the state or something of that. Okay. Now, let's jump into another concept which is interrelated to this concept called table space in Postgre. Okay. I will go little bit fast because I have a few more things to cover, but not the, I'll try my level to talk about all the concepts step by step, but I will focus more on the important concept first. So table space. What is the normal understanding of table space with the with the understanding of the other databases? What is table space? What do you understand with table space? Anyone?
It's
It
logical
contains data files.
container.
Mhm.
It's a
One by
logical
one.
name of
Mhm.
it's a logical name of physical files actually.
Okay. Logical name of physical file or group of physical files, right?
Group of physical files. Yeah.
Sometimes we have group also. What about Sheikh? You were telling something, right? What do
Yes,
you
something
think?
similar. In Oracle, tablespace contains one or more data files.
Mhm. Very good. Okay. So what is the end of the story purpose of table space? Why do we need table space in database? Segregation, I'm fine. You mentioned that we want to segregate the data. I'm fine with that. But what is the whole purpose, the ultimate purpose of table space?
It is, a physical storage location on the disk
Mm-hmm,
drive where actual
mm-hmm,
data files, for the objects related, like
mm-hmm.
tables and indexes are stored.
Okay, got it. So, if you ask me, what is the whole purpose of table space? Definitely segregating the data into multiple files or logical name for a database in the storage unit or in the storage level. I'm distributed my database into multiple files. My database is a logical entity. I have distributed that into multiple files, file 1, file 2, file 3, file 4. So end of the story, if you just remove your database administrator hat or specs and see from the operating system, technically what we are doing, or let me give you an example. You have a file. This file was keep on getting the data. Let's suppose this is a normal text file. Initially, it was 1 MB. Going forward, it is becoming now 1 GB, then 1 TB, then 100 TB or 1000 TB. So what is happening here? Data is growing, right? From 1 MB till 1000 TB. So from the IO level, from input and output level, when this file was small, it is very easy to do the operation, right? It will be very easy. The moment it is getting little big, okay, it's fine, we can do that. Even this is also fine. But in this level, sometimes what happens when your file size is big, and second thing, your file is a single file, IO becomes slow. Are you agree with that? If you VI a very long log file, sometime it hangs, right? Or sometime it takes time, right? To open. Let's suppose your log file size is 4 GB or 10 GB or 15 GB. So if you are doing VI on Linux level, it takes time, right? So in the initial release of databases, what people found that if they are storing all the database related thing or all the blocks into the single file, if a single file, what will happen going forward, IO is going to be a bottleneck. Okay. So when we have bottleneck, or technically if I have a single pipe from where my IO is going, or from where I am using IO, let's suppose this could be anything. This is my disk, this is my IO. So if I want to go to the next level, or if I want to give more performance to any system, database is just part of that. Okay, anything is running on the operating system. There is a concept called IO channelization. Okay, that's why sometimes what you do, you create C drive. C drive is coming from one disk, and your D drive comes from another disk. So what technically we are doing, we are channelizing the IO into two parts so that our overall operation speed is going to be increased. Okay, so same concept, database, the people who developed the database, they have identified, they said, when my database is small, I have only one disk. Under that disk, I have the data files. The moment my objects are growing, the moment the objects are growing inside the database, this IO is not sufficient. Okay, so what I have to do, I have to channelize my IO. So I will add one more disk. So when I will add one more disk, how my database is going to understand the next disk? So what they did, they invented a new concept called tablespace. Tablespace is a logical name of to holding multiple data files. Okay, so let's understand in a very high level and a broader level. This is your database. This is your table. This is your table. Two tables we have, table A, table B. Table B is growing like anything. It is growing in the rate of, let's suppose, terabytes. I have a single disk which is attached to my system. Both the tables are residing here, but I am getting lot of transactions. I'm getting lot of transactions for table B. What technically is happening, I'm getting a lot of IO for my table B. Okay. And let's suppose if this is a bottleneck in a production, what is the next thing that we do? If we think from the channelization of IO, what is the next option that you can give me the answer with your existing database knowledge also,
We
because
can
this
add another disk.
we can add another disk. But adding another disk is just an addition in the OS level. We also have to move this table to here, right? Directly, can you move if your database is like work as a coupled architecture, right? Coupled architecture means multiple files, multiple physical files, multiple blocks are coupled and they called as a database, right? Can you decouple one of the table's data
No.
technically? No. So then what got invented? Tablespace got invented. So using tablespace, what I did, I have moved this particular table to a different tablespace, and this tablespace get allocated to this disk 2. So what is the advantage that I'm getting here? The biggest advantage I'm getting IO channelization. performance is increased because previously a single pipe or single interface was connected to my disk, which was giving me, let's suppose 35,000 Mbps speed. Now I got another disk with 35 Mbps speed. So now users will get more performance, right? Yes or no? Yes or no? Well, do you understand
Yes.
this concept first of all?
Yes.
Using Tablespace, I have added a new disk, and what happens? The overall performance got increased because now I have two hands to work. Previously, I was having only one disk, one interface connected to my server. Okay, makes sense. So let's go and understand. Yeah, any question? Yeah, Rohit.
In terms of cloud, it's a on-premises
Hmm.
one. If we go for the in terms of cloud, how these things work out. So
Okay,
in terms of cloud.
okay. So in terms of cloud, basically, let's suppose you have a AWS, and in AWS, first of all, you have EBS volume, right, attached with your
Mm,
instance or something.
mm,
So let's take an example of EC2. You have created your
mm.
virtual machine on AWS. So what you do, you add one more EBS or EFS, whatever is like, but it's supposed to be blocked storage only. It should not be any other S3 or something. Postgre doesn't support that. It should be
But about the
blocked
RDS
storage.
service, will it be the same concept? Will be on RDS service?
RDS is completely managed by AWS. So
Okay,
you
okay,
don't have any control on tablespace level.
okay, okay.
They will do everything for
Mm,
that. Okay. So uh, when you are doing when we have a class of production planning, we have a
mhm,
dedicated session for production planning. So
mm.
there we are going to talk more about all those things. But here, as a high level, do you understand this? Like I have created the table space previously, database. Okay, now let me introduce to the Postgre level of tablespace knowledge so that you understand it properly. So basically, in a Postgre database, we have two kind of table spaces by default, which is available. One is PG default, another is PG global. Okay, PG global and PG default. So what is PG default? The basically whenever you are creating a new database, it goes to PG default table space. Okay. If you create any new database, this particular table space is used. The existing catalog tables, the existing metadata of your entire cluster, okay, is stored into which? Into PG global. So mean to say whatever catalog tables that we query, right, or whatever metadata commands that we run, the data comes from this table space. And this is the table space when we create a new database. Let's suppose create database name. So that goes to PG default. Okay. So if you want to understand this on a very high level, let's understand two things, okay, which will create your concept very well inside your mind. So basically, table spaces are working on two levels, object level. So mean to say I have created a table and I have moved my table space to TA, for example. Also, it works on session level. As I always mention, the Postgre databases are very modern, very advanced. So they gives you option of working on session level also. So mean to say, when you are connected to a database and you define that in my session level, this is going to be my table space. Whatever data you are going to create, whatever objects you are going to create, it will go to that particular table space level. So object level means when you are creating the table, when you are creating the schema, or anything. You have just defined that my table space is going to be T1. When you have connected to the database in the session level, if you say my database is table space is going to be T1, then your entire session data will go to that particular table space. So this is two important concept you have to understand. Okay. Basically, if you are a Oracle DBA, for you, this part is going to be more relevant. If you are a MySQL database administrator, this part is going to be more relevant because they don't have session level concept. As per my knowledge, I might be wrong. So object level. So what happens? They are creating the table space, and they are attaching it to with a user or a database. So whatever activity happens to this database, technically data goes to this table space, and these table spaces are having multiple data files. So actual data is going to be stored in these data files. Okay. High level concept, at least you are clear what we are talking about here. At least some of the high level things. Is that clear? At least.
Yes. Abhishek, I have a doubt.
Mhm.
Anyways, if you're going to create an object level database, table
Mhm.
space means if you're
Mhm.
creating a table that will be stored in a page level, right? In a
Correct.
PostgreSQL system. So, what about if we have we have created two table space for a certain table, for a huge table, how the defragmentation will be handled between these uh, table spaces? Uh,
Okay. Let me explain you all the things from the beginning so that you will understand. So basically, a database, objects, page and block, right? These are the common concept, right? In all the databases, or at least in Postgre and Oracle, right? You
yes.
have database, you have objects. Some in basically in some databases they might call a different concept also segment. In Oracle they call it segment. So segment is nothing but a collection of blocks,
Pages.
pages, and then group of segments are nothing but your objects like table, index or something, right? So your question is like how uh, can you just repeat your question one more time? What was your
Uh,
question?
Actually, for a huge table, consider
Mm-hmm.
we have a,
Mm-hmm.
5 GB of 500 GB or
Mm-hmm.
600 GB of table. We have segregated that table in like in
Mm-hmm.
SQL Server we have the secondary
Mm-hmm.
file, right? So kind of here we are segregating this in a two table space for a single
Mm-hmm.
table, and that table is highly transactional.
Mm-hmm.
So how the fragmentation will be handled? That's my question.
Fragmentation, when you say fragmentation means what exactly? Like,
If the pages will be high level of DML happens means the delete and update happens means the new block will be created, right? The old one will be not until we
got it, got it.
yeah.
So we have a concept in Postgre called MVCC that
Okay.
I'm going to cover. So there, basically, you're talking about the how undo is going to be managed, right?
Yes.
How the multiple version of the data or data blocks or pages are. Yes, I'm going to cover in MVCC. So I'll explain you detailedly how it happens. Like in Oracle, it happens with undo table space, but here in the table itself, we are managing with the help of old and new version of the block,
Okay.
and it is getting stored in the same table. That's why we are running the vacuuming process. So I'll explain you that in MVCC clearly.
And one more doubt.
Yes.
Uh,
No
uh,
problem. You can ask any question. Yeah.
Yeah, the thing in MySQL, we have a table space will be there. A single level for each table level, we can maintain a table space, or else a
Correct.
single table space for entire
Default
database.
one.
Yeah. Likewise, in here we can do what it will be
You can do.
configured on in
Yeah.
a RDS level also we can do.
No, RDS
No,
level, I
that's
don't think you can't do. It is managed by AWS. But here you can do. You can create n number of table spaces and you can attach with your database. One more thing I want to tell you related to your question. Uh, there is a concept called toast.
ah
You must be knowing toast also, right?
yeah. I have a doubt on that also.
Yes.
Later I will
So
ask.
yes. So let's suppose uh, this is all the this is whatever I am discussing. It is on the Postgre level, okay? But let's suppose I want to manage my objects also in a such a way so that I'm getting the optimal performance, okay? So first of all, there is a concept of toast. Toast, what it does, it handles the entire big objects or the objects that are in a very big in the nature of in the their overall object size is quite big, and you can't store all those objects or the data inside a table. Then what we do, we also have a concept called toast in Postgre, okay? But I don't know if I want to do it in Oracle, I have to buy a different license. I think Nagesh, are you do you have any idea about that? If I want to handle, let's suppose I want to store big MP3 file, MPG file, how we can handle in Oracle? Like
We
we
can
have a
handle
different.
like,
Mhm.
yeah, club and blob we have, that is not licensed. But when we go
Mhm.
for the compression, hybrid level column compression, at that time we have to purchase the license.
Hmm. So here it is completely full, completely free. Okay. So the the full form of toast is the oversized attribute storage technique. Okay. Why I brought toast into the discussion when you have talked about the big objects. This is one of the interview concept that comes again and again sometimes in a big company, because companies like YouTube, companies like Instagram are managing big objects into the database itself. Okay, so we have to understand the toast also. Okay, I will explain toast also in a minute how we can handle it. Yeah, Jason, you can ask your question.
So what you're saying is toast is nothing but if a oversized data is there in a table, so it will be moved to a toast. Is that what you're saying?
Correct. We have a separate mechanism to handle the large objects. Like in
Okay, it's
Oracle, we
like a,
have blob. Yes,
yeah, the same. Yeah, in DB2 also we have the same.
correct. So
Okay,
DB2, is
so
it licensed one or it's free?
licensed one.
Okay. Okay.
Yeah. And moreover, this in DB2, what we have by default when a database
Mm,
get created, so there will be
mm,
three default table spaces. One is for catalog, one is for
mm,
I mean default users, yeah,
mhm.
user table space, and one is for temp. Okay, so likewise, do we have anything for temp in Postgres? I mean,
Temp is
you
getting
said that
hand.
there are.
Yes.
Okay,
Mhm.
yeah, you said that there will be default is for users and global is for global is
Mm,
for
mm.
system catalogs, right? So do we have anything? I mean, for temp to handle the temporary tables, do we
No,
have
it is
anything?
not. It's not a concept of table space as a temporary space, but it handles temporary table space using PG temp in a different file itself, which can be
Okay,
also we can do multiplexing like Oracle.
okay,
So
but
it's
it
not a
will be,
concept of, yeah.
but it is not created by default. We have to create that manually.
No, it is created by default. It is by
Okay,
default. It is there. PG underscore temp is there,
okay,
but it is not handled on the table space level like Oracle, like DB2, MySQL. I'm not sure how it handled, but it is not like that. Here we have
it is
only
it
two
is handled
tables,
in the file
file
level.
level.
Okay,
Yes.
got it. Thank you.
But if you want to understand all these things, when you are understanding the table space, make sure you also understand the toast, because sometimes that comes into the discussion. So in a very high level, Postgre got two tablespace, PG default, PG global. PG default is the default tablespace where whenever you create a new database, that particular data goes to that particular tablespace. PG global, all your catalog related or metadata goes to the PG global. For further understanding, object level, session level, I have clearly distinguished it here because this is the core concept. Object level, session level. Okay. In other databases, you might not understanding this like object level, session level, because you have never understood these concepts like that. But here we have concept like object level and session level. So you can handle your entire database table spaces in these two levels. So just make a mind map that there is something like this. Okay. So that you can understand all these things properly. Another thing, uh, table spaces are normally related to IO when we have to reduce the IO, when we have to reduce the overall IO bottleneck or throttle, we use table space. If you ask me what is the core concept, why table space are used, so this is the core concept that I want to reduce the IO input output from one single channel to another channel or one single interface to another interface. Okay, RDS, Azure, all the managed services are not giving option you to manage the table spaces. It is only available when you are creating your table space. Okay, is that fine? Clear, everyone?
Yes, Abhishek.
Okay, so let's do small practical of table space, and let's create one small table space and understand how it works on the Linux level. This was the machine we used yesterday. I don't think so. One second. Where's my machine cluster? Anyone remember the machine name which we used yesterday? Postgre new. Let me see this one, if this one works. CD. Are you people using Vagrant, like installed and using it? Everyone?
Yeah, I've installed, but yeah, it is in. I mean, I'm facing some issues.
Okay. If you need any help, just let me know. I'll help
Yeah.
you to fix your issue.
Yeah.
Okay.
So while the system is coming, do we have a default page size in Postgres? Like DB2, we
Yes.
have a. Okay.
Yes.
So what is the size? Is it 4K, 8K, 16 or 32?
It is. I think it is 8 KB,
Okay.
the default size. Yeah.
And
And
what is the maximum limit it can handle?
maximum limit, I think, in terms of the you're talking about the how to
Yeah,
in
in
what
DB2 we
extent.
have yeah, non-temporary table spaces.
Yeah.
We have like regular table space. We have large table
Mhm,
space like that.
mhm,
So
mhm,
for a regular table space, 4K can handle 8 terabyte. So that
mhm,
is a maximum limit it can grow. So it
mhm.
cannot grow beyond that. So such is there anything like that kind of scenarios in Postgres? Like there is a limit, a table space can grow only up to this max limit? Is there any limit?
I think there is a limit. but let me check what is the max limit. If you have proprietary version installed like Percona and other thing, then specific to EDB, I think they give you few more options to handle your block and other thing. But I think it can go up to what I can see. 1 minute. Up to 32 TB
Okay. That's quite
maximum.
good. Yeah.
Yeah, that's quite good. But I don't think it is going to be on the single table space level. It might be multiplexed by multiple table spaces
Okay.
or something. Yeah.
And in DB2 by default a table there can be multiple tables can reside in a single table space in a normal scenario. In a partitioned table we can have multiple table space. Okay, for example, the data will reside in a single table space and index will reside it can reside in a separate table space and lobs can reside in a separate table space. That is for DB2. Okay, is that anything like
Same
for
concept.
same concept? Okay.
Same concept. What we do, we create table space for 1 second. Huh? I'm just getting a call. Just give me a second. So same concept. We create table space for data. We can create table space for indexes like that. So
Okay.
same thing you can handle here.
Okay, but for a table, there
For
will be only
partition table
one.
also you can create different
Okay,
table space.
yeah. For partition table, there can be multiple
Yeah,
table spaces, but
multiple table space.
for a normal table, there can be more than one table space
Yeah.
in terms of
No,
data.
no,
I'm saying.
no.
Okay, got it.
Table object, you cannot create, you cannot distribute the same object into multiple table spaces. But
Okay.
in the distributed databases like ClickDB, TIDB, you can do that.
Okay, and all
Or
the data
YogaDB.
resides.
Yeah.
Okay, and all the data that all the objects that we create, those objects reside only on the table spaces. Is that correct?
Only table space, correct.
Okay. Okay.
So there's no other other place where your data is going or getting segregated.
Okay, and in turn with the table spaces, there on the beyond table space there are containers in DB2. We call that. Okay, that are the physical files that reside in the disk. Okay, so like that, do we have any concept? I mean, we call table space as a logical object, whereas containers are physically located in the disk. Okay, and tables are also they are also logical objects that reside inside these table spaces. Okay, so like that, do we have any separation like logical,
So
physical?
when you say container, what that mean? Like
Container in the sense it's like they call like a physical file, they call it as a container. Okay, containers. Okay, so internally if you go to the disk and if you see, there will be the data resides in terms of the container files only. They are physical files.
Got it. So here also we have temp managed like that, but it's not container, it's just a file.
Okay.
So which I think you have just called it container because it's containing something. But here also there are some files which is containing the configuration, containing the temp data, staging data, and some of the files are just holding the metadata, like log files, other things like that.
Okay. Okay. So
But
if you
concept is
open,
same.
okay, got it.
So you got your answer, or you have any?
Yes.
further?
Yes, I got. Thank you.
Anyone else? Like any doubt? Anything which is coming inside your mind, which is important or you want to discuss? Because going forward, we are going to correlate these table spaces with other topics also. So that's why. Okay. So whenever we have to list the table spaces, what is the command?
DB. Yeah.
Right, DB. So here we have PG default, PG global. Okay. So now what I want to do, I want to create a user. I want to create a user, and I want to create a table space, and I want to assign that user or the object to that particular table space. Okay. So for that purpose, first of all, we are going to create a table space. So before I go and create the table space, what I need a physical place, right, where I want to store my table space related data. So let's suppose in my computer, I have let's suppose I have a separate disk, for example. Currently, my PG data is residing where? PG data is residing here, and this comes from where? This is coming from root, this volume, right? For example, I want to create my new database from OPT TBS. Okay. So let me go and create it from root. Okay. So I have created a OPT, given the privilege, all the privilege to Postgre. Now let me go and test it whether I have the privilege or not to create the file. What is the command to test the file level privilege, whether files are getting created or not? Touch command, right? It creates a dummy file. So using touch command, we can test whether the current location is having the correct privilege or not. So this privilege is ready. Now simply I will log into my database. I will see how many table spaces are there. There are only 2 table spaces. So what I will do, I will create a new table space, create table space. Another important thing as we are discussing about it, how many of you understand linking in Linux?
You mean soft link, hard link?
Soft link and hard
Correct.
link.
Soft link and hard link. So sometimes you will see that people are creating a base mount location like this, base mount location, and from there they create multiple links to the other mount points, and they are creating the table space. So knowingly I brought this topic here. It's not a good practice. Try to mount the volume directly. Don't create the links. First of all, how many of you understand links?
Yeah, links are there are 2 types. One is hard link, soft link.
Hard link
Soft
and
link
soft
are
link.
yeah. So soft link have the I mean hard link have different index number, whereas soft link has same.
Same inode values and link numbers,
Yeah,
right?
yeah. And
Okay.
if soft link, I mean, if the original source file is not available, the hard link will persist. Whereas in the soft link, if we delete the source, the soft link will not persist. It will show as a red. So
Correct. So whenever you are creating your table space, do not use linking method. There's a specific reason behind that. The moment you use your linking method, when you are upgrading your database, you might see a lot of challenges. And technically managing the links are not a right way of doing anything in Linux operating system. This is just a bandage. This is not a permanent fix. So whenever you are creating a table space, make sure you mount your own specific volume like this. Do not use direct linking method. Otherwise, when you will upgrade or your server is due to some reason your server is down or your links got deleted and all, so which is very risky operation. Always create your table spaces with the specific path. Okay. How many of you understood this statement? Create your table space with the specific path. This is something which creates disaster. So test TBS, and I'm going to give the location. What is my location? I'm going to give this location, this particular location. So like that, a table space is created. Okay. So now let's suppose I want to create a user. Okay. So, or I have existing user, for example. I don't have any user here. Let me quickly create a user. So, and first we will create the user uh, with the default option, and then later on I will show you how you can change the user. Create user, test user with password, and I'm going to give the very normal password. This user is created, right? Now what I'm going to do, I'm going to give the user as this particular table space. So what I'm going to do, I will simply write a command. Or do we have any? No. So let's create a table also.
So Abhishek, in DB2 we handle the users are handled in OS level. So in Postgres is it handled by Postgres or it is handled
It is handled. You can handle both the levels. So we have a file called pg indent file. So if you want, you can also map your OS user with your database user, option 1. Option 2, directly you can create the way I created.
Okay.
So this is important. This option is only for the kind of environment where you have, let's suppose 1 million, 2 million databases. Okay. And it will be practically impossible for you to go and create the users in each and every database. So what you do, you simply push your indent file to the database. So what happens, your system username, let's suppose my system username is Oracle, and I want to map it with my Postgre database username like Postgre. So within a minute, once you will push your indent file, all the mapping will be established using automation.
Is it indent dot what is the extension?
Indent.config.
Okay, what is the path of that?
Same, your PG data holds this particular.
Okay.
You can think like PG data is your base storage of your DB2, mean to say. DB2 might be installed in /u01 or something like that, right? So this is the main storage point.
Okay, storage in the sense the data, I mean,
data or the home directory, you can say.
Yeah, I mean, the table space reside, or I mean, we have a different path for data and home directory.
So it's like this. Your base directory, where your Postgre and Postgre binaries are residing. And this is the moment you create the table spaces, the table space will go to a different location like that. Or you can create inside your base directory also. It's up to you. Like the default and global is already holding the space, right? This space, it's like that. Okay, so let's go and I think we have created the table space. Let's quickly see that. DB, my table space is created. So now, once my table space is created, what are the two level that I can do? What are the two level I can hold? Set this session level and table level, right? Object level, right? So let's suppose, let's create one more table space so that I will show you that answer of that question also. where you were asking about indexes, right? So like that. Okay, so let me create another directory. I'll cover everything one by one. So mkdir/opt tbs1 chown post.
Tab 1.
Yeah. Okay, so now we have two table spaces. One is for table, another is for index. Okay, so now let's suppose I have a table called tab1.
Abhishek, with the same location directory,
Mm-hmm.
can't we create two table spaces? It errored out, right? Every table
Right,
space need a different path.
a different path.
Okay.
Mm,
Create
text.
table.
One second. Create table tab1 name text. Name text. Will it take text? Yes, perfect. Insert into tab1 and let's take it text1. Values. So into tab1 values, this might go.
I think you need to give it in single quotes.
I have given in the single quote. What? Yes. So inserted this 1, 2, 3. So this is the problem when you work on multiple databases. So
Yeah.
from tab1. So how many databases, how many rows we have? We have 3 rows. Okay. So now let's move this particular table to the table spaces which we have created. Okay. So let's do alter table. What is my table name? Tab1 and set, and I will give my table space as tbs1. Okay. Set. See here. This is the beauty of Postgre. When I do tab, it clearly gives me the option. So I will select table space and my table space name. So this is my table space. So I got this got altered and db. So now if I will do dt, let me describe this table space table. tab 1. Can you see here? So this particular table is going into this particular table is going into this particular table space. Same thing you can do. Let's suppose if you are creating a index. So I don't have any index on the table, but in the same way, you can set your indexes, alter index, index name, set table space, and you can send your index to this particular table space. Okay, makes sense like that.
Abhishek.
Mhm.
So when we move one of the table from one
Mhm.
table space to another table space,
Mhm.
in that case, we'll be requiring a downtime, right?
In that
Like as
case,
it is not on the fly, right?
on the fly, no, it is not on the fly. You need a downtime, or you have to plan it ahead of the time when you are creating your table or your schema like that.
Okay. And for example, now I have one table A in another table space and B in another table space.
Mhm.
Now, when the developers will be querying it, so they do they need to mention the table space name in order to query, or
No,
is
not
it
at
like
all. No, no. Yeah, yeah, please. Mhm.
yeah, like I got it, like you said, not required, right?
Yeah.
Okay.
Abhishek, when you just create a table, which default table space will it go? Like you moved it from tables to a table space. When you
Mhm.
just run a command create table,
Mhm.
where will that table store?
It will go to your default territory, PG data. If you are not defining anything, it will go to your PG data. And if you are defining a path, it will go to that specific path.
In RDS, we don't have the privilege to move anything apart from PG data, right?
No, you don't have any privilege because in RDS, they are creating everything. They are managing everything on backend.
So everything goes to PG data itself.
No, it's not like that. It's not like that. So they have a concept of channelization. So they manage all these table spaces and everything based on their configuration. But the moment you use Aurora is using storage level IO channelization. Mean to say they are storing the table space in a different storage. It's altogether a different storage. That's why you're getting the performance. But in RDS, they are not allowing you to give the option to change the table space and all.
Abhishek, so
Mhm.
if we create object and we don't
Mhm.
specify the table space,
Mhm.
it will go
Mhm.
to PG default, right?
PG default. Yeah.
Okay. So you moved
See,
the
think
table.
like this. Think like this. Whenever I'm doing, see, simply think like this. Whenever I'm not defining anything, create database test. By default, it is going into my default table space. Let me give you the
PG
query also. Yeah,
PG default.
yeah. So there is a query. Let me run that and we'll get the clear cut understanding when we are not defining it. So let's see. So OID. So let me get the OID of this particular data. OID. There is a query to get the OID of a specific database. So let me get that OID, and using that OID, we will come to know which particular database is residing on which particular table space. So the common concept is if you are not defining any table space or anything while creating the database, it will go to the default. The moment you define it, it goes to that uh, particular table space. But uh, it is only possible when you have the specific storage or specific mount is available. Mean to say when you are defining it, so you have to plan all these things ahead of the time. That's why we are going to discuss everything when we are doing to do the production planning. So I'll make you understand that how you can decide all these things ahead of the time. Mean to say your storage, your table space, your config parameter, the user privilege, all those things. Yeah.
So Abhishek,
So
is that the command which I have mentioned to get the OID?
this is the command. See here. So you mentioned what? Let me see that also. Yes, this is the command. If you put your database name here, you will get your the OID. And let's suppose this is my database. So 2489 and 2489 is going to reside. Let me get the query also. Okay, I'll get the query later, mostly after the break or something. But at least we are clear about all these concepts, the table space and other thing. Is
Abhishek,
that clear?
one doubt.
Mm-hmm.
Usually Oracle side, we have the database first and within the database table space reside,
Mm-hmm.
right?
Mm-hmm.
So here it is vice versa, like first it's table space, within the table space database gets created.
Come again, what you are asking?
Like
Within a. Mm-hmm.
you created a table space first, and when you
Uh-huh.
create a database, you run a create database command. The database is going to the table space, right?
The database is
I
going to
mean,
the default table
I
space.
mean, what he's saying is, yeah, in DB2 also the same concepts. Okay, the database is a bigger picture. Okay, and inside
Mm-hmm.
database there will be plenty of table spaces. Okay,
Yeah,
whereas what
correct.
he's asking is, yeah, whether the here the table space is the uppermost globe, and inside that table space the databases will be there. Is that the question? That's the question.
Yes, yes, correct. You're right. Yeah.
So, mean to say you are asking that uh, technically your PG data is the place where all your database related files goes. Okay. The moment you create a table space, you are defining a new storage unit, let's suppose U01 or OPT, to store your data. So by default, if you are not defining anything, it will go by default on PG data, which is a storage, you can say it's storage mount. Under that, it will by default go to the PG default. PG default. The moment you decide it, or the moment you say that I want to store into different table space, then only it will go to a different mount points. Make sense?
No,
Abhishek,
the question is,
Abhishek, I think
Mm-hmm.
what we are trying to in Oracle,
Mm-hmm.
the relationship between table space and database seems to be different from here. We
Mm-hmm.
want to understand the relationship
Mm-hmm.
between table space because it looks as if in a table space in
Mm-hmm.
Postgres, you
Mm-hmm.
can have multiple databases. That is not the concept in Oracle. So that I think that is what we want to clarify. In Postgres, from your explanation, it looks as if in one
Mm-hmm.
table space, we can have multiple databases, which is not like that in Oracle. So I think
No,
that
no,
is
no,
what
no. No, it's not like that. That single table space can be used by multiple. It can used by multiple tables, but like in Oracle, what we have a user. That user goes to a specific table space, and that table space have multiple files, right? That is the concept, right? In Oracle, right? User user have his own table space, or database is having multiple table spaces, right? That's what is the concept of Oracle, right?
Yes.
Yeah, but one particular you are right. One particular table space in Oracle can only be used by a particular database. But from what you are saying there, it looks to me as if multiple databases can use the same table space in Postgres, but that is not the concept in Oracle.
Yes, that's not the concept. It's entirely different. So basically, in Postgre, table spaces are just a storage location. Okay, and they are used only for the objects. They are not divided for the user or divided for the database. No, it's not like that. It is segregated between all the cluster. Okay, and in Oracle you have 101 concept, one database, one instance, one set of the files. Here I'm talking about the entire cluster. So when I say cluster, it means I have multiple databases running on my Postgre. Okay, and your table space can be used between these databases. That's what is the concept. Because by default, when you install Postgre database, you get two table space. All these databases, whatever are getting created, if they are from the system, let's suppose if they are holding the metadata and all, they will go to PG global. Okay, the new one, whatever you are creating, the new database that you are creating will go to the default, PG default. Okay, the object, let's suppose you are creating object and using the default, you don't want to use the default table space and you are creating a table. Let's suppose you are creating a table, you can assign a separate table space for that particular object.
Okay, so
Like
Abhishek, yeah, to be clear, okay, so for example, I'm creating DB database 1, database 2, database 3, okay. So the database 1 will in the database if I'm creating a database, okay, so there will be a default table space called PG underscore global and PG underscore default, okay. So what I have understood is, so for each databases, okay, each database contains what is that the catalog tables, right? So those catalog tables will go to the PG underscore global. Is that correct? All the databases
all the database related metadata information will go to PG global, because
okay.
it has to hold the metadata of your
Okay.
table, like column,
And
table, everything.
what about the user data? I mean, for example, DB database 1, database 2, database 3. Let us have three database. Okay. So for the three database, the user tables will go to the PG underscore default by default. Is
Default,
that
by default.
okay? So which means table space is the uppermost. Then I mean, it is the superior. It is on the superior than the database. Is that what you're saying? The reason is in DB2, what we call, whenever we are creating database, okay, the database is a bigger globe, okay, and inside database there will be each and every database contains its own catalog table space, okay, user table space, and temporary table space, okay. So database is the bigger globe, and inside that there will be these default table spaces will be created, okay. So so we can connect to a database, then only we can create these table spaces, okay. That is a concept in DB2. I think that is the same concept in Oracle as well, right, guys?
Oracle is more like
Yes.
101. There we have one table space and one database. The entire database itself is having one table space or multiple table spaces, right? We can assign
Yeah,
multiple table
yeah,
spaces.
the same.
Yes.
Yeah, same concept
Here,
in DB2.
yes,
Yeah.
but here it's a shared architecture.
Okay, got it.
Got it, right?
Got
Here,
it. Yeah.
my object or metadata will go to the PG global because it has to handle the information about my table, objects, index, multiplies view, anything. But my actual data is going to be on the default table space. Again, on the object level, if I want my table to use a different table space, then I will create a different table space. It's like that.
Okay.
But
Just
And what
Oracle
about the session? I mean, how
session
we
also, when you are creating a user, you can also say that this particular session is going to use this particular table space. So whatever uh, data will be created by that session will go to this particular table space. So I can understand there will be a lot of confusion, but think like Postgre is a cluster database. It's not a single database like Oracle.
to just simplify our question,
Mm-hmm,
Abhishek,
mm-hmm,
we are just looking for an hierarchy. Like
mm,
without a table space in Postgres, we cannot create a database, correct?
correct.
Okay. It's vice versa in Oracle and DB2, I guess. Without the database, we cannot create a table space. First, database needs to be created, then within that,
exactly?
we'll
Exactly.
create a table spaces. But here,
Correct.
first, we define table spaces and we just select whichever the default table space or any other table space within that database gets created.
Yeah,
Perfect.
that's right. And the
And
higher
the superior, the word you use, right, which is having more power or superior. So it's not like that. It's a shared architecture.
okay. And in DB2, apart from the database, there is an one more concept we call as instance. Okay. So instance
Mm-hmm.
is a independent environment where we can
Environment.
have
Mm-hmm.
yeah, it's an independent environment. Okay, where we can have like one in a particular instance. Okay, we can have multiple databases. Okay, and if we have an instance two, and in the instance two, we can have multiple databases. Okay, so the instance one database, we call it as DB1. The instance two also we can have the same database DB1. Okay, but
Mm-hmm.
those are all different environment. I mean entity, so that
Mm-hmm.
they don't clash with each other. I mean the name does not clash with each other.
Mm-hmm.
So is there anything in Postgres? Is there anything like superior than tablespace? I mean like the is there anything like instance or anything do we have here?
Okay. So first of all, in DB2 and Oracle, if I'm understanding correctly, in DB2, you are, or in Oracle, you are creating a separate instance itself, which you call as a SGA, right? For each database, right? Each database have it normally gets its own memory space, which you call it SGA and background process, right? Something like that, right?
Yeah,
But
yeah, in yeah.
separate instance means a memory area which is dedicated to a specific database, right? Like that.
Yeah, instance is like a like what we call like with the help of instance only we can be able to create the database.
Database.
Yeah, so that
So,
it's like a like the instance will have its own port. It will have its
mhm,
own. It's a bigger one. Okay, so
mhm,
the I mean instance has its own memory. Okay,
mhm,
so it's like a instance level. We have a globe parameter, some sort of
mhm,
higher
mhm,
parameters. Okay, so
mhm.
down to that, we will be having multiple databases, and each database has its own set of configuration
Set of
parameters. Okay,
configuration. Correct, correct. Same like Oracle. So you have an instance, but in Oracle, instance is dedicated to only single database, right? In DB2, I'm not sure. Is
yeah,
it
in
dedicated
DB2
to
that
multiple?
yeah, multiple databases can be created.
But in Oracle, it is single instance, single database like that.
Okay, it have a, I mean, it in a single instance, we have instance level memory. Okay, and in that instance level memory, these instance level memory is shared between the databases. Okay, so for
Mm.
example, if I have three databases, okay, so each database can have its own database level memory in that instance level
Instance
memory.
itself.
Yeah.
Yes, correct. Same concept here also.
Okay.
We are not managing individual memory or individual instances. We have our own single database instance, let's suppose, which is started by Postgre postmaster process. And these databases are created in the single instance, this instance.
And
Whatever
this
database we are
postmaster,
creating.
yeah,
Mhm.
yeah, this postmaster process is is the main, I mean, that is the main process. Is that correct?
Correct.
Okay,
This
like the
is the
same
main
way.
process. Mhm.
in DB2 we have DB2. I mean, we have DB2 sysc. Okay, that is the main process. So under that only all the other sub process will come. So for each instance there will be one main engine process. We call it as DB2 engine process. So that is DB2 sysc. Okay, like that in Postgres it is postmaster. Is that correct?
Correct. So if I have ps3 command, and if I just go to this particular process, I will get the whole hierarchy. Can you see this? So postmaster has started everything. So postmaster is the main process. And if you go here and see all the child and like parent and child relationship, see here, the parent is postmaster process. So postmaster process is the process which starts your entire database. And in other words, answer to your question, this is your instance. And this instance is catering to all these databases. This instance is catering to all these databases. But little change, little difference from the Postgre point of view. The moment I connect to my database, I will only get a different background process. The moment I connect to this database, I will get a different background process that is going to be separate from this particular process.
I think like you're
Getting my
saying
point?
about
Yeah.
local Abhishek.
Sorry.
Something is if something like suppose I just connected from the PG admin or some other tool, then we can see that particular backend process under the postmaster only, right? Which is not going to be separate.
No, it is going to be separate. It is going to be dedicated channel connected to my database. It will come under postmaster only or under the
That's
Postgre,
right.
but it will be a separate process altogether. They are not going to
Obviously,
share.
these are backend. These are
backend.
background. That is backend. So
backend.
both are completely different. I agree.
Completely.
But I can see the
but in
PS3
Oracle,
under. Yeah, go ahead.
No, you just complete your.
No, I can see from my side, like, so when we establish the backend process for the particular session, I can see under the postmaster only.
Right.
Yeah, go ahead, please.
So basically, if you want to compare this knowledge with your existing database knowledge, in existing database like MySQL or Oracle, your backend process are not getting created again and again. If a new database connection comes to the database, it is getting handled by a single process. In Oracle, I think it is PGA, right? Or listener process, which is controlling everything. But here in Postgre, a new backend session is going to create a new service altogether or new process altogether. Okay. In MySQL, it is getting handled by threads, right? If I'm correct. So that is the difference, and that is the another downside of the Postgre also. Okay. Later we'll talk about that. When we create multiple sessions, let's suppose I have 1,000 connections, so I will see 1,000 processes running here in my server. Okay. So back to my main topic. Is this clear to everyone? Whatever we have discussed so far. And this was a very good discussion that we had today.
And the port number, regarding the port number, there will be only one port for the whole set of the cluster of database, right? So for example, if I have 5, so 5432 is the whereas in DB2 we have we have like let us say if I have 2 instance, okay, 2 instance will have a different port number. Okay, so since they are different entities, okay, so they so if I have 2 instance, 2 instance have its own port number. Yeah. So is that like in Postgres we have like the one port number can there is only one port number for all these databases. Is that correct?
Yes. So it's not one-to-many relation, it's one-to-one relation. One instance, one postmaster, one port. Netstat command is not installed. Otherwise, I have clearly shown you that. 1 minute. Net tool is the actual command. 1 second. Oh God, we'll take a break. Better 1
Yeah,
minute. Let
we'll
me
take a
show you
break. Yeah.
this. Let me show you this and then plain grep 5432. See here, only one process which will handle by postmaster, and you can't create multiple ports for the different databases.
Okay. So, but we can customize the port number, right?
We can customize the port number. It can be handled by your
ETC
configuration.
services.
No,
Slash
it
ETC.
is configured by your postgre.conf. Like this.
Okay, so in DB2 we have there are 4 set of configuration parameters. We have database level configuration parameters, we have instance level configuration parameter, we have profile registry level configuration parameter, and the topmost is environment level configuration parameter. So these are all the 4 hierarchies. Okay, the lowest one is database level, then instance level, then the third higher level is profile registry configuration parameters. Then the environment level comes. That is a topmost hierarchy. Okay, like that. Do we have any other apart from this Postgres configuration parameters?
No, it is symbol centralized one is only postgre.conf, postgre-auto.conf. That's all.
Okay, auto.conf is the hierarchy, higher level, or
Auto.conf, no. It's not like that. So it's like postgre.auto.conf is having more value than postgre.conf. So
okay, got it.
if you are doing any changes from your command line alter statement, it is getting noted in the auto.conf. So whenever your instance is restarting next time, same like your p file, sp file concept in Oracle. So it's
Okay.
like that. Yeah.
Okay. Okay, so let us take a break.
Yes, let's take a 20-minute break today so
Yeah,
that people get some relief.
and yeah, so please stop the recording and start the timer.
Yes, sure.